Yes, good morning, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S Exam Prep. And, guys, as you know, this session was about to start at 10 a.m., but because of some technical network issues, the session was delayed. And at 11 a.m., we are starting this. But, guys, don't worry, we are going to solve all the problems of these past years from engineering mechanics and strength of material for both mechanical and civil branch. So guys, please tell me, am I properly audible and visible to all of you or not? Yes, Sagni, good morning. Yes, so I am properly audible and visible to all of you or not? Please tell me that. Yes. Hello Teju. And guys, do like and share the session so that other students can also reach. Good morning, dear. Yes. Good morning, Nagaraju. Fine. So now we are starting the session, guys. So guys, in this session, we are going to see the previous year's questions of these 5 years when IIT Kanpur have conducted the GATE exam. And we are choosing two subjects, strength of material and engineering mechanics. And the questions will be taken from both mechanical and civil branch because these two subjects are common to both the branches. So guys, without wasting your time, we are starting the session. Those who are watching me for the first time, for all of them, this is a small introduction. Yes, Parth, hi dear. So guys, I am having around 10 plus years of experience, cracked GATE and many exams many times, written many research and review paper, and these are my areas of expertise. So guys, let us start the session. And as you know now, BYJU'S Exam Prep is a complete solution to your preparation journey of GATE, engineering services and other competitive examination. Yes, Pawan, good morning dear. So guys, now we are starting. This is your first question. Okay. So I have not mentioned the years, but I have taken all the questions from those 5 years from engineering mechanics and strength of material. Okay, so guys, let us see the question. Yes, this year IIT Kanpur is going to conduct GATE examination. Okay, so that's why we have taken those years questions. Okay, so guys, this is the first question. A free bar of length L is uniformly heated from 0 degrees Celsius to a temperature T degrees Celsius. Alpha is coefficient of linear expansion. E is the Young's modulus of elasticity. The stress in the bar is. Yes. You need to answer this question. Okay, Sagnik have said the answer is C. Guys, do like and share the session because as this session is delayed, so many of the students would not be aware that the session is going to start. Okay. So just try to share it in all the Telegram and WhatsApp group. Yes. So Sagnik is saying answer is C. What about others? Some questions would be easy, some questions would be difficult because they are previous year's question. They are not question made by me. The great horizontal, okay, Hazik is also saying the answer is C. Very good. Parth is saying the answer is C. Okay, fine. What about others? Pawan, Nagaraju, Teju. Okay, C. Very good, guys. So guys, I would say that yes, you guys are correct. The answer is going to be C. The reason is they have mentioned a free bar. So my dear, when free expansion occurs, in the cases of free expansion, there is no thermal stresses actually. So thermal stresses are 0 in the cases of free expansion. But yes, if somebody asks you about the strains, then my dear, all the strains are coming out to be alpha delta T. And you know, volumetric strain is given as 3 alpha delta T. Yes. Let us see the next question, guys. This is the next question, guys. Very good question. The next question is a 200 cross 100 cross 50 mm steel block is subjected to a hydrostatic pressure of 15 MPa. So dP is given as 15 MPa to all of you. Then my dear, the Young's modulus and Poisson ratios are also given to us. E is 200 GPa. then Poisson ratio is 0.3. You need to find out the change in volume, my dear. You need to find out the change in volume. Change in volume. So my dear, this is the question. Very good, guys. If you want, I can give you a small hint to solve this. You must be aware of that when we are going to define an elastic constant. You need to find out volumetric strain, which is dV by V. You must be aware that bulk modulus is said to be dP by volumetric strain. So my dear, if using these two elastic constant you can find out K, then definitely you can find out volumetric strain. And for that you need to go for the relations of elastic constants. You must be aware of that E is equals to 3K into 1 minus 2 mu. So using this you can find out the value of K. And using this you can find out volumetric strain, and using this you can find out change of volume. So my dear, this was a very good question. Sagnik have given the answer as B. What about others? I am waiting for others' answer as well. What about others? Sagnik said the answer is B. What about others? Very good. Teju is also saying B. So guys, this is a golden chance to revise all the previous year's question of that year. And we will be going for all the subject one by one on all weekends. So just be ready with that. Okay. So in this way your revision will also be done and you will be able to solve all the problems. So you will be having a good practice also. And if some conceptual clarity is required, you will be getting that also. And whether the book you have, their solutions are correct or not, that also idea you will be getting. Very good, guys. Very good. So I feel many students have given the answer. Sai Krishna is also saying B. And guys, yes, B is the correct answer. Can you tell me what would be the value of K using this relation? Very good, Sushil. Can you tell me what is the value of K? Because E is 200. 3 times of K. 1 minus 0.6. What you are getting as K? Then finding out this K, you will be putting here, you will be getting volumetric strain. Then you will be getting the change of volume dV as 90 mm cube. Very good, guys. Very good. Malesh, wonderful, dear. Wonderful. So Sagnik have given the value of K as 166.67, and yes, it is correct. This would be coming in GPA. GPA, dear, GPA. Okay. Yes, fine. Because this is in GPA, so that would also be in GPA. Wonderful. So let us move further, guys. And guys, do like and share the session. We are going to solve more than 40 problems. So this is the next question. This is the next question. A steel rod of length L and diameter D fixed at both the ends. So there is a steel rod which is fixed at both the ends, uniformly heated to a temperature rise of delta T. There is a temperature rise of delta T. The Young's modulus is E. Coefficient of linear expansion is alpha. The thermal stress in the bar is. What easier than this question is? So dear, it is easier, but this is previous years. I cannot change previous year's question. So whether it is easy or difficult, it will be coming in front of you as it is. Okay. So I have just gone through year by year paper, and whatever the question from SOM and mechanics I have taken. Okay. What about this question? Sagnik have said C. Teju have said C. Yes. So guys, this is both and fixed case. Both and fixed case. So this is the case when we are saying both ends are fixed. So when both ends are fixed, my dear, when both ends are fixed, my dear, you can see E is Young's modulus, alpha is coefficient of thermal expansion, delta T is the change of temperature. So my dear, you know, for this case, how we are going to find out? First of all, delta L is defined as L alpha delta T. Then you can define the strain as delta L by L, which is nothing but alpha delta T. Then we are going to define stress is E times of epsilon, that will be E alpha delta T. So answer is C. Wonderful, guys. This is the next question, guys. Question number 4. This is a stepped steel shaft shown in the figure is subjected to a torque of 10 Newton meter. If the modulus of rigidity is 80 GPa, the strain energy of the shaft is. Yes, very good Mangu, very good Hazik Imam, Sushil, Parth, Malesh. Kishan, don't worry. Don't worry. For that, I have taken the practice session separately. If you remember, last month I have taken a complete marathon on SOM and TOM, which were other than gate question. You can see the level of those questions. I feel you found it good also. So guys, don't worry. For those kind of marathon, I am going to come now every week. Okay. I was waiting till your subject gets completed. Now you will be getting that level of question also in the marathon. But previous year's gate questions are also required. If you are talking about previous years, questions are very good. Just for 3-4 years, they are easier. So sometimes easier, sometimes difficult they have been. In this session only, you will see 8 to 10 very dangerous question also. Okay, but yes, that practice session where I was taking every question as dangerous, that will be coming next week. So we are going alternatively, 1 week previous years, 1 week practice session. So be ready for that. Solve this question, guys. Like this question, they are asking strain energy. You can assume this to be shaft 1 and this to be shaft 2. And you know that strain energy is a scalar quantity directly added up. So you will be saying U is going to be U1 plus U2. And you also know that U1 will be defined as half into T1 into theta 1. And you know theta 1 is given as T1 L1 G1 J1. So you can write U1 as T1 square L1 by 2 G1 J1 and U2 as T2 square L2 as 2 G2 J2. Now my dear, you can see diameters are given. J is defined as J1 is pi by 32. Pi by 32 or 64? Yes, it is 32. So pi by 32 D1 to the power 4 and J2 will be pi by 32 D2 to the power 4. You can see D1 is 50, D2 is 25. Lengths are given as equal, and as the torque is applied at free end using method of section, you will find out both T1 and T2 are equal and they are equals to 10 Newton meter. Yes, any doubt please ask, guys. Very good Mangu, but I need answer. Like Sagnik have said, the answer is C for this. Let us see. Okay, very good. What about others? Okay, Mangu, very good. You have given answer also. Very good. Wonderful, dear. Yes, guys. Keep on solving. I want answer from all of you. And do like and share the session. We want more and more students to join this session. It is a important session. Yes. Teju, Parth, Malesh. Very good, Mangu. Mangu Kia Kenil, very good. Yes, Kishan, Teju. What about others? What about others? I have given you the formula. Guys, keep your calcies with you. Okay, without calci it is difficult to solve. And they are gate problems. As I said, some question will be easier, some would be difficult. So that depends, because complete paper are not coming tough. Okay, neither before nor today. Yes, Sushil, Malesh, Parth. What about you guys? You need to just put the values now. Torques are given to you. Method of section you can apply very easily. Okay. So my dear, when you will be putting these values, you will be getting U1 plus U2 and it will be coming out to be. Yes. Only calculation parts are pending. Rest I have written in front of you. So this is a 2-mark problem. Obviously 2.5 minutes in the exam you will be getting for this. Okay. So I would say yes, the answer given by you, C, is correct. So the strain energy would be coming out to be 1.73 Newton mm. Okay guys, yes. So this was question number 4. Let us move to the next question, question number 5. This is again an easy question. So don't worry, very good questions are also about to come. Which one of the following types of stress strain diagram relationship best describe the behavior of brittle materials such as ceramics and thermosetting plastics? What would be the answer for this question, guys? What would be the answer for this question? Yes, yes, yes. Let me share the session. I feel you guys are busy in solving problem. So let me do the task. Yes. Fine. Okay, very good. So Sagnik, Parth, Teju, Kenil. Very good. So all of you are saying the answer to be D, and I will say your answer is correct. The reason behind this answer is, guys, in this session, actually whenever you follow previous year's book, you must be getting the solution. But the solution you are getting in this session are more authentic. Okay, so you will be getting the correct explanation for everything. My dear, when we are saying material is brittle, it means brittle materials have less or zero plastic strain. Okay, because brittle means those who are not ductile. Ductility means plasticity. And you can see this region is plastic, this complete region is plastic, here this region is plastic. So only this is the diagram where there is no plasticity. So that's why D is going to give you the correct idea about this question. My dear, question number 6. Question number 6. Yes, it is a numerical answer type problem. It is a numerical answer type problem. Okay. So my dear, a rod is subjected to a uniaxial load. A rod is subjected to a uniaxial load within linear elastic limit. When the change in the stress means D sigma is 200 MPa. The change in the strain is 0.001. Poisson ratio is 0.3. You need to find out the modulus of rigidity. This question is from elastic constant. This is a pure elastic constant problem. Because you know that Young's modulus is defined as D sigma by D epsilon. Okay. And my dear, this is mu and G. You know E is equals to 2G 1 plus mu. You need to answer about G. So you need to solve it. I feel Sagnik have given the answer 76.92. Okay. What about others? Guys, do like the session also. Do like the session so that other student can also reach here. Okay. This is really a motivation so that I come to know whether you want these types of session or not. Yes. Very good. Teju, Nagaraju, Anil, Kishan, Kenil, Parth. What would be the answer to this question? What would be the answer to this problem? It is 200 by 0.001. It will be coming out to be 200 GPa. So 200 2G 1 plus 0.3. You will be getting the G to be 76.923. So all of you, those who are giving this answer is correct. Abhishek, good morning dear. Yes guys, wonderful. Teju, very good. Anil, very good. Kishan, very good. Wonderful guys. So guys, this was question number 6. Now let us move to question number 7. This is a basic conceptual question for 1 mark. For a simply supported beam, on two end support, the bending moment is maximum usually at support, always at midspan, where there is no shear force, where deflection is maximum. So bending moment is going to be maximum where? Dear Abhishek, actually when they are giving in this way, then you must understand that when you are having a stress strain diagram, as your question is, you know that if we are going to take the slope, then you can take this like this. So this is sigma 2, sigma 1, epsilon 1, epsilon 2. So you can take this relation. This is mathematical slope relation. So don't worry about that. That kind of thing can be given. Okay, this question many students are giving different answer. So dear, when they are saying there is a simply supported beam, if you have a simply supported beam, my dear, then they are saying bending moment is maximum where? Dear, at support there is no chance. Some options, some student may be saying B, some may be saying C. But my dear, it is not always at midspan. You must have seen a case when you were having this is not UDL, this is UVL. In case of UVL, my dear, you will be getting the maximum bending moment not at midspan. In case of UDL, you are getting. So if loading changes, then you cannot guarantee that maximum bending moment will always be at midspan. But you know a relation that bending moment, when you are going to define, dm by dx is shear force. So my dear, you are talking about bending moment maximum. You must be aware that when bending moment is going to be maximum, at that place dm by dx will be 0. Okay, so shear force will be 0. So the answer is going to be C for this. The more clear, the best, the correct answer. Is it clear for everyone? Yes, Anil, are you getting? So when loading is not symmetrical, then my dear, bending moment is not going to be maximum at midspan. Is it clear? Ram Yadav, in all the top 7 IITs, design is at top, thermal is majorly at second number, third is manufacturing. So that is a good idea. Good. I don't know other than this what you are getting. If you are getting it the best option, then it's fine. But if you are getting IIT Bombay, IIT Chennai, then they are better. Okay. Let us move to the next. So guys, here force is acting here, and let me show you the force actually for this case. 100 Newton force is acting here. 100 Newton force is acting here. Yes, you need to answer about the maximum bending moment for this case. So my dear, for this kind of case, you know, first of all, you need to take the effect of this force at longitudinal axis of the beam. For that, you will see at this point there is no force acting, so you will apply two equal and opposite forces. This is 100, this is also 100. So this 100 and this 100, they are going to create a couple. So my dear, you will be having a simply supported beam now, on which at center there is a force 100 Newton. 100 Newton into 100 mm is the couple. So this is 100 Newton into 100 mm. Unit you need to take care of. Okay. And my dear, you know, for this kind of case, you need to answer about the maximum bending moment. So for that case, my dear, you must be aware which type of bending moment diagram we are getting for this case. So I am without taking care of sign convention. without taking care of sign convention, giving you an idea. It will be coming something like this. So you need to find out this value actually. Okay. You need to find out this value actually. I have given you an idea. Okay. That how to find out this. So you can do one thing, that find out this support reaction and bending moment at this point C. If this is A, this is B. You can write it as VA into 500 mm plus this bending moment M. So this is how you can find out. Sorry, plus M as per the sign convention. Yes. Kishan is saying, okay, Sagnik is saying 8B, 30 is the answer. Abhishek is also saying 30 is the answer. Okay, let me check it. Very good. Very good, very good. Very good, guys. So if you find out the support reaction, my dear, it will be coming out to be 40. It will be coming out to be 60. So when you will be, this is the BMD I have made directly. You know, we have done this type of question many times in the class. So with the way how to find out support reaction, you know, VA plus VB is equals to 100. Taking summation moment about A to be 0. Then you will be having VB into 1000 mm. This is positive. Minus 100 into 100 mm is equals to, okay, this also will be creating. This is anti-clockwise, this is clockwise, this is again anti-clockwise. Plus 100 into 500 mm. Putting it to be 0, you are getting the value of VB. So you will be getting VA also. VA and VB are known to us, my dear. After getting VA and VB, you know 40 into 0.5, because 500 mm means 0.5 meter. Then plus or minus. Is this okay? This will be coming plus 40 or minus 40? Yes, plus this is 100 into 0.1. So this will be coming out to be 30 Newton meter. Answer will be B for this. Wonderful, guys. Kenil, very good. Sagnik, very good. Abhishek, very good. Anil, Ram, Sushil, Teju, getting it or not? If any doubt, do ask me. I have given you the way to find out. You will be getting this as 40 Newton, this as 60 Newton. Is it clear for everyone? Yes, guys. So I am majorly giving you how to find out solution, as there is no need to make BMD. I have made it just for the reason so that you can understand. Like if you see my support reaction at VB is 60. If you want to find out this bending moment directly also, you can find out. This distance is how much? This is 0.5. So 60 into 0.5 is also 30. So you will be getting this as 30. Actually, this is how the jump is going to occur. I could make this BMD without any SFD also. I told you when you will be practicing, you will also be able to make it. But for this question, there is no need to make SFD BMD. I have made just for the sake those students who have studied like that, they can directly solve it with this diagram also. Otherwise, this is the general way to solve what I have done actually. Okay. Part. Okay. So if you want to know how I have plotted, I am telling you. Don't worry. So my dear, this VA will be coming out to be 40 Newton. VB will be coming out to be 60 Newton. You know, here there is a force of 100 Newton and there is a moment of 100 into 0.1. It means 10 Newton meter. Okay, this is what is given to us. Now, my dear, if you are going to make SFD for this, Then my dear, you will be going for the sign convention. You know, this is one section, this is another section. To the left hand side, I am showing the sign convention also. Sign convention for shear force are this: positive, negative, positive, this negative. Guys, those who are saying, sir, how you have plotted this BMD, I have used the empirical relation method, the slope method which you say. So you must be aware that whenever we are going to make the shear force diagram, to the left hand side of the section there is a jump of 40 Newton. So we will be having a jump 40 Newton. It is positive. Then A to C there is no other load. It will be going like this. Then my dear, 100 Newton is coming. This section to the left hand side downward is negative. So it will be going down by 100 Newton. So this is 40. This will reach to minus 60. And it will reach to this, and because of this 60 it will come 0. It will become 0. So this is going to be the SFD. Now my dear, we are going to make the BMD. If SFD is a horizontal line, BMD is going to be an inclined line, that we know by the slope method. Those who don't know slope method and want to study that, please write in comment section. Then I will be making a session specially on SFD BMD, and I will teach you this shortcut method to make SFDs and BMD. So if this is a horizontal line, we are going to get inclined line. You very well know that the area of SFD is giving us BMD. So we can write bending moment at C minus bending moment at A is equals to the area of shear force diagram. So this is 40 into 500 mm. 40 into 500 mm. So my dear, you know that as this is a roller or hinge support, so MA is going to be 0 at the support. MC will be coming out to be 20. And you know, if this is horizontal line, bending moment is going to be inclined line. So my dear, I will be making this as 20, joining this 0 to 20. In the same way you can do for this case. You can write this point was B. So you can write, my dear, what? You can write MB minus MC is equals to this area, and this area is minus 60 into 0.3, 60 into 0.5, sorry, 0.5. And this will give us, my dear, MB is already 0, because at support bending moment is 0 for roller support as well as for hinge support. Okay. So you will be getting MC to be 30. And you know it is horizontal line, 1 degree more will be inclined line. So diagram will be coming like this. Now you know at one point, if we are getting these two values, they must be joined like this. So this is going to be the bending moment diagram. So maximum value is 30. So those who are aware of this slope method, only those students go for this. Other student go like this. First of all, support reaction calculation, we have gone through summation vertical 0, then summation moment 0. You need to go like this. Those who are knowing the slope method, they can very easily plot SFD BMD and get the answer. Okay, so if you really want to learn this method, you can message, you can comment that, sir, we want a session on this. I will be planning. If you really want. Actually, I have taken before also. Okay, you can watch the recordings available also. Question number 9. This is from compound beam now. This question is from compound beam. Compound beam. The favorite topic of GATE, compound beam. Yes, guys, solve this, solve this. I want answer from all of you. Very good. Yes. Hello, Torsion. Hello, dear. So guys, this is a question. A cantilever beam OP is connected to another beam PQ with a pin joint as shown in the figure. a load of 10 kilonewton is applied at the midpoint of PQ. The magnitude of bending moment at the fixed end O is. Very good. Sagnik is saying the answer will be 10 kilonewton meter. Okay, we will see. I feel very good, Sagnik. Wonderful. Yes, very good, Gana. Ganpati Babu, very good. Kishan, very good. Nagaraju, very good. So you can see how easily you are solving the compound beam problem. Yes? Wonderful, guys. So my dear, if you see this propped cantilever beam, if you see this compound beam, you know there is a procedure to solve this. You know there is a procedure to solve this. Okay, this is Q, this is P, this is O. And my dear, if we have this force as 10 kilonewton. So you know, to solve this type of problem, we need to divide them in two parts. Like this. And you know, we are going to put a support reaction here as VP and the same force here as VP. Because there is no force at P point. This is internal hinge. So we are providing VP here so that the net here is also 0. Then my dear, you know this distance is 2 meter and this distance is 1 meter. So here the load W is acting as 10 kilonewton, and by symmetry you will say the support reaction VP is going to be 5 and support reaction VQ is also going to be 5. And my dear, if that is the case, you will be putting VP as 5 and 5 into 2 will be the support reaction, moment reaction. MO will be 10 kilonewton. Sir, we have to separate, then there will be 2 reaction extra. Very good, Kenil. Very good. Very good, guys. Wonderful. So guys, this is how you can solve it, or you can also apply directly the moment at P is equals to 0 also. By that also you will get the same. But this is more easier, Kenil. Okay. Yes, Kishan. Let us move to the next problem. This is a wonderful problem, guys. This is the best question from SFD BMD, I will say, till this time. This is the best question. Okay, because it is an overhanging beam. So my dear, you need to find out first of all the support reaction. Then you will make SFD and then will be finding out bending moment. So here you need to plot SFDs, BMDs both. Okay. Very good, guys. Very good. So guys, this is going to be a support reaction RA. This is going to be a support reaction RB. First of all, you need to find out the support reaction. Then we will talk about SFDs and BMDs. You can see this is 4 meters. So I am helping you, as there is no shortcut applicable in overhanging beam. RA plus RB will be 60 kilonewton. Then my dear, you will be taking summation moment at A or B to be 0. So when you will be putting, this was summation vertical 0. Now I will go for summation moment about A to be 0. You know this HA and RA will be passing from A. You can see this UDL and you can feel that this entire UDL is acting at its centroid. So 40 kilonewton is acting at 2 meter distance. This is creating clockwise. So you will say plus 40 into 2. RB is creating anti-clockwise minus RB into 4. Then this 20 will be creating clockwise plus 20 into 6. You need to find out RB. Try to solve and give the answer, guys. You will get this 40 into 280, 120. So RB will be coming out to be 50. So RA will be coming out to be 10 kilonewton. 10 and 50. Now, my dear, we are going for SFDs and BMDs. Okay. So let us make on the next slide. This is 10. 4 meter is UDL. This is 50 kilonewton, 10 kilonewton per meter. After 2 meter, there is 20 kilonewton. 2 meter, 4 meter. We need to go for, my dear, SFDs and BMDs. We need to go for SFDs and BMDs now. Okay, guys. Very good, Sagnik. Very good. So when you will be going for SFDs and BMDs, you know that first of all, we need the sign convention. This is going to be positive shear force. This is going to be negative shear force. This is going to be positive bending moment. This is going to be negative bending moment. Okay, guys. So now we need to make SFD. So you know that from A to B, there is one type of loading. From B to C, there is another. I told you when type of loading changes, then or other support comes, then you need to change the section. So we will be having section 1-1 like this and section 2-2 like this. Okay, guys. If you want, I can go by writing the equation also. That will be more favorable for you maybe. So V11, you can write it as, this is VA. So we can write it as VA. It is going to be plus because to the left hand side upward is positive. Then you will write minus W into X. You can see X ki power 1 means a straight line equation. This is 10 minus 10X. So when you will be having this equation, putting this to be 0, you will get X is equals to 1 meter. And you know this equation is valid from A to B. So putting X is equals to 0, you will get VA as 10 kilonewton. Putting X is equals to 4, you will be getting VB as 10 minus 40 minus 30 kilonewton. So my dear, if you want to plot SFD, I could make like that also. There will be a jump of this support reaction. Then as this is a horizontal line, UDL is considered as horizontal line. So SFD will be an inclined line. Inclined line will go like this. You have 2 point, this value is 10 and this value is 30. You know there is a jump. There is a jump of 50 kilonewton again. So minus 30 to 50 will be this 20. Go up to 20. Total is 50. From B to C, there is no other load. You will go like that. And my dear, because of this 20, you will be ending at 0. This calculation was not required for me, but I have done it for you so that you guys can understand how the things are coming. So this is the SFD. I wanted to find out this distance. That's why we have done in this way. Now, my dear, when you are going to make the bending moment diagram, you must be aware where shear force changes its sign, bending moment is going to be maximum. So my dear, one point is B where shear force is changing its sign. Other point is this D. So either at this or at this point, we will get maximum bending moment. So you must be aware that here shear force is horizontal, bending moment will be inclined. Here shear force is inclined, bending moment will be a parabola. So if you want to find out how it will come, then bending moment at C minus bending moment at B is the area of SFD between these 2 points. This way I have taught many times on YouTube. If you have not seen, guys, we will be having a separate session for that also. Otherwise, you can learn how we are doing. This is 40 kilonewton meter. You know very well that bending moment at C is going to be 0 at free end. So you will be getting bending moment at B to be minus 40. So minus 40 means this diagram will be coming like this. I already know because of horizontal line, it will be inclined line. So inclined line from 0 to minus 40. Then my dear, it is going to be 0 here. That is also for sure. If I want to find out bending moment at D, you can write bending moment at D minus bending moment at a area, half into 10 into 1. Half into 10 into 1. This is coming out to be 5. So my dear, you know MA is 0 because at roller or hinge support from the starting we will be having 0 only. So MD is coming out to be 5. So if MD is coming out to be 5 means positive like this. You know, because of this inclined line we are going to get parabola. Here you can see the value of shear force reducing. You know that the slope of bending moment is nothing but shear force. So if you are saying shear force is reducing, slope of bending moment will also reduce. So bending moment diagram will be coming this parabola. Here the slope is maximum, here the slope is 0. Then at the same time shear force increasing, slope will increase. This kind of parabola you will get, and the answer will be the maximum magnitude is 40 kilonewton meter. So this is going to be the maximum value. Are you getting it? How wonderfully we are plotting this bending moment diagram and SFD? Guys, please tell me, are you comfortable with the way I am plotting it? Do you know this way or not? If not, so that I can go in a more explanatory way. Okay, because I am going casually because I feel you everybody know how we are doing. This way everybody have been looking for many number of times. So answer will be 40 when we are going magnitude wise. Okay. Next question. This is a propped cantilever. This is a propped cantilever. So those who were saying that questions are easy, now good questions are also coming. Yes or no? Very good, guys. Very good. Very good. Very good, guys. So solve this question now. This is a propped cantilever beam. Both the diagrams are given, but I feel this diagram is enough for us. I am giving you the name for this. A, B. Okay. They are saying this reaction R1. This reaction R2. M. So guys, Q is the load intensity given to us. Sure, Kishan, sure. We will definitely plan one session, a marathon only, where I will teach you how to plot SFD BMD with slope method. Okay. Pavan Kalyan is saying answer is A. This is a very general question which I have done many times in the class. Let us see how many of you give the right answer for this. Pavan is saying the answer is A. Sagnik have given C, then deleted. Yes. Teju is also saying A is the answer. Very good, Sagnik and Kenil. Wonderful, guys. Wonderful. So, guys, really wonderful. You guys are going really awesome. Answer is A only for this. So, my dear, you know this is a case of propped cantilever beam. Here, if you see the number of support reaction, if I show you generally, we are having this as UDL. So, there is a support reaction, there is a support reaction. Let us say this is VB, this is HB. There is HA, there is VA, there is MA. So, you know, if you see all these support reaction, we will say HB is 0, HA is 0 because there is no horizontal force. Then we will go for summation vertical to be 0. And we will say VA plus VB is equals to Q into L. You can see this is one equation. Then we will go for summation moment about B to be 0. You can see this MA is anti-clockwise, so minus MA. Then my dear, this VA is creating clockwise plus VA into L. Then this total load we will be assuming it at the CG or centroid Q into L, acting at a distance of L by 2. So we will be writing in that way, my dear. This is creating anti-clockwise. So minus QL into L by 2. Then my dear, VB and HB are passing from the same point. Moment will be 0 because of that. So if you see, this is equation number 2. My dear, equations are 2, unknowns are 3, VA, VB and MA. So 2 equations, 3 unknowns, we cannot solve it. If that is the case, we need an extra equation. We know at this point support is present. So at point B, deflection will be 0. You know, at point B, deflection will be coming because of 2 reasons. One is because of this UDL. You will be having YB as minus WL4 upon ATI. W is given as Q, so minus QL4 upon ATI. And my dear, the second is coming because of this force VB. So this is going to give positive deflection, this is going to give negative deflection. So this will be YB as VB L cube upon 3EI. You very well know that these two are going to be 0. Why? Because Y at B will be Y at B because of Q plus Y at B because of VB is going to be 0. I will add them. Minus QL4 upon ATI plus VBL cube upon 3EI. Putting it 0, you will get VB as 3QL upon 8. So when you get VB value, my dear, you know VB is nothing but R2. So R2 is 3QL by 8 here also, here also. So either A or C will be the answer. You know bending moment at A cannot be 0. So because of that, C is wrong and A is correct. Okay, so no need to calculate further. I wanted to tell you this thing. When you have this type of option, no need to go for complete calculations. Only one small calculation can help you in solving the complete question. Okay guys, moving to the next problem. Question number 12. This is from deflection of beams. This is from deflection of beams. A cantilever beam with flexural rigidity of this. So EI value is given to us as 200 Newton meter square. The deflection at the tip of the beam. If this is A, this is B and this is C. You need to find out deflection at A. I feel everybody is aware about how to move in this case. Do you remember guys? I have taught you principle of superposition. And I taught you when you have this kind of condition how to deal with this. Yes. Got it or not? This is deflection at A. This is deflection at B. This is a straight line. Slope is theta B. Because there is no load from A to B, it will remain a straight line. This angle is also theta B. So you can write YA as YB plus theta B into AB. Are yes or no? Wonderful Pawan, wonderful dear, बहुत ही बढ़िया शानदार. अभिषेक, कैनिल, सागनिक, तेजू, किशन, Anil, Nagaraju, Parth. Wonderful guys. So my dear, YB, theta B, AB. You know my dear, if you consider this as L, this as also L, then I can use the formula theta B as PL square upon 2EI, YB as PL cube upon 3EI. Here P is 500 Newton. Okay, L is 50 mm. Solve it guys, solve it. Tanu, there are no options for this question. There are no options for this question. Okay, 1 by 4, Canil have given the answer 1 by 4. Means you want to say 0.25. Okay, what about others? What about others? I am waiting for the answer. Yes, Sagnik. Yes. Solve it, solve it. Fine, Kenil. Yes, I know it is calculative. Will take some time. But I need answer from all of you guys. EI value is directly given to us. Wonderful, guys. So, after solving, you will be getting deflection at AS 0.26042. Okay, guys. This will be the answer. Kishan, you are making some mistake. Answer will be 0.26042 mm. This will be the answer. The length is 50 mm here. So you need to put length here, load here, and EI is Newton meter square. So when you will take care that load is P. This is 50 mm. So 50 into 10 power minus 3 ka square divided by 2 into 200. Okay, this is how you will be doing. Very good, Sagnik. Tanu. Question number 13, my dear. This is again from deflection, and here we will be going for moment area method because they are asking deflection at Q. So I am helping you slightly for this. Those who don't know about BMD of this case, I am showing you them. This kind of bending moment diagram will be coming. And this value will be PL. You need to find out deflection here. Let us say this value is some X. Or let us take some other K. Okay. So my dear, this is given that this is 100 and this is 20. You need to find out deflection for this case. You will write deflection or slope. Actually, you need to find out slope. So you will write theta at Q minus theta at 0 is equals to 1 upon EI, area of BMD between Q and O. Means you need to consider this area, one rectangle and other triangle. For that you need to know this value, and for this value you need to go for angle similarity of two triangles. One triangle is this, another triangle is this. You can write PL by 100, K by 80. You will find out the value of K. And after getting K, this is first area, this is second area. You will write 1 upon EI, A1 plus A2. So you will be finding out theta Q like this. Sir, most of questions were from SFD BMD part, slope and deflection part. Nahi, Kenil, before these 4 questions are from SFD BMD part. Before that we have seen other questions also, and after that also some questions will be coming from Mohr circle and all. Actually till now we have solved only 13 questions, na? So also that depends that sometimes questions are coming. Actually one question is coming every year from SFD BMD and deflection part. Similarly, one question is every year from simple stress chain plus thermal stress part. So we have seen 5-6 questions of that part. Now this part, then you will have principal stresses part, column part. So 4 to 5 questions are coming every year, and one from these 2 to 3 chapters it is coming. Okay. Because in previous year's question, I have taken first as simple stress strain, second chapter as SFD, BMD and deflection. So you are getting these questions right now. So Sagnik is saying 0.1587, Tanu is saying 0.1587, and guys, you are correct. The answer will be 0.1587. So they are more calculative type, but I have given you how to find out them. Load is given to us, length is given to us. We have just used them. Okay, use them, put the values and get the answer. So answer for this is 0.1587. Is it clear, guys? Okay. Now, my dear, this is whole actually. This is whole. Okay, this question is from mechanics, that we will say later on. Now torsion is coming. Yes, canal, now torsion is coming. Yes, canal, actually sometime weightage are going to increase or decrease. There is no fixed rule actually. If you see at the time of 2019, 17, 18, there 13 to 14 marks of SOM also have been asked. So we cannot say that it is going to be less always or more always. You can take an average of 8 marks. Sometime it will be also 4 marks also. Sometime it will go till 12 marks also. So 8 marks you can consider that it will be there. Okay, that you can hope. This question is consider a stepped shaft subjected to a twisting moment applied at B. Okay, and they are asking that the angle of twist at C. So you need to answer, my dear, the angle of twist at C. So this is shaft 1, this is shaft 2. So just solve it, guys. You need to find out theta at C. Yes. So dear, questions are there from every part. Very good, guys. Okay, someone have given the answer also. Look at carefully, dear. They have asked answer in degrees. That is where the twist is. You don't have the options. So my dear, this is a numerical answer type question. Many students would be doing a mistake. They will find out theta in radians. They will not convert it into degrees. So do convert it into degrees also. You can see there is no torque in BC part. So as there is no torque in BC part, so theta C with respect to B is going to be 0. So theta at B will be equals to theta at C. And you know theta at B can be written as T1 L1 by G1 J1. Put the value, get the answer. You will be getting theta B value. Then convert it into degrees. Okay. 180 by pi. Solve it, guys. Tanu have given the answer. Kenil have given the answer. बहुत बढ़िया Sagnik. Sagnik have given the answer. The answer is 0.237. Is it clear, guys? Wonderful. Let us see the next question. The next question is once again from torsion. Now Kenil will say, sir, all the questions are coming from torsion. It is not like that. I am taking 5 years question in front of you. So those 5 years questions are in front of 5 year. So 5 year questions are in front of you. So my dear, obviously for the same topic, there will be 3 to 4 questions at least. So a hollow shaft means they have given K as, K is defined as di by d naught. It is 1 by 2. And they are saying power is 20 kilowatt. Power is 2 pi nt by 60. Find out torque from this. Then you know tau is T by ZP. And they are saying permissible less than equals to tau permissible. You will get the value of D naught. Very good. AA, Tanu, Kenil, Sagnik. Yes, Teju, where are you? Teju, where are you? So guys, wonderful. Still many questions are there. We have actually, this session was planned for the timing of 10 to 12. But because of some network problems, just at the timing of class, we need to shift it by 1 hour. Very good guys, very good. बहुत ही बढ़िया. बने रहना है guys. Be planned for every Sunday. Be with us every Sunday. I am thinking that every Sunday we will give you that kind of power pack to you, which will help you in your exam. Okay, so be ready. Yes, Teju, then solve the question. So I already told you that soon we will be having the test of SOM also. Don't worry, we are planning, we are working on it. Okay, so be ready for that. Kenil is saying 11.29. What about others? Kenil, do check it once. Maybe some mistake is there. Is it DI or DO? Yes. So you know what is ZP actually? ZP is pi by 32 D naught 4 1 minus K4. This is going to be D naught by 2. This is ZP. Very good. Sagnik, AA, Tanu, your answers are correct. The answer will be B. It is going to be 22.58 mm. It is going to be 22.58 mm. Very good guys. Wonderful. बहुत ही शानदार. बहुत ही शानदार. Question number 17, once again from torsion. So dear, you can see for mechanical, torsion is very, very important topic. Out of 5 years, this is 4th question. Out of 5 years, this is 4th question. Okay. I already have told you that simple stress strain, strain energy part plus thermal 1 question. SFD, BMD, deflection 1 question. Okay. So there is in that way, principal stresses, thin cylinder and spheres, theories of failure 1 question. So a hollow shaft of 1 meter length is designed to transmit a power of 30 kilowatt and 700 RPM. The maximum permissible angle of twist, this is maximum given. The inner dia of the shaft is 0.7 times. The modulus of rigidity 80 GPa. You need to find out the outside diameter. Similar question you can say guys, very much similar. Previously they have given in the previous question that maximum permissible stress is this one. This time they are saying permissible angle is this one. So you need to talk once again in the same way. Power is 2 pi nt by 60. This will give you the value of torque. Then you will write theta as TL by GJ is less than equals to theta permissible. And my dear, this will give you the D naught value. Solve it. Very good, Kenil. After this question, we have question from principal stresses, thin cylinder. Okay. So questions from all the areas, whatever they have been asked in those 5-6 years, we are covering all of them. Okay, guys. So Kenil is saying 44.831. Okay. What about others? So some students are really working very good. And I remembering those days when in the same way we were taking classes, Parvinder was there in the class. In the same way some students are responding. So I am expecting this time more results like Parvinder. He got AIR 3. This time I can see 5 to 6 students who can get in top 10. Definitely yes. Why not? But you need to continue this till exam. Okay. Till exam, the same level of dedication should be there. Okay. Very good, Kenil. What about you, Tanu and Sagnik and Teju? Solve it, guys. Solve it. Very good, Sagnik. So answer is correct. Sagnik's answer is exact. 44.5. And yes, the exact answer is 44.5212. But yes, it's fine. Others answer are also in range only. 831 is also in range. Okay. Yes, that is also in range. AA, very good. So guys, this was question from torsion. Now we are having the questions from principal stresses. Okay. That is transformation, you say, for civil peoples. A cylindrical elastic body subjected to pure torsion. This was T. Is it fine? Yes, guys. Vinay, very good. Very good, Vinay. Okay, Sagnik is saying D is the answer for this. A cylindrical elastic body subjected to pure torsion about its axis develops tensile stress in a direction of 45 degree, no tensile or compressive stress, maximum shear stress along the axis of the shaft, maximum shear stress at 45 degree. So my dear, when we are having pure torsion, in pure torsion the state of stress is like this. Everybody is aware of that. And in this case we have principal planes at these locations. So these are obviously at 45 degree from X face. So my dear, yes, the answer is going to be D. Is it clear? Yes. Yes, answer is D for the previous. Very good. Sajan Rosh, Vinay, बहुत ही बढ़िया. Now we are having question number 19. An elastic body is subjected to a tensile stress X in a particular direction and a compressive stress Y in its perpendicular direction. So what they are saying is this. One is tensile, other is compressive. X and Y are unequal in magnitude. On the plane of maximum shear in the body there will be. So this question you can solve it very easily using Mohr circle. This is X, this is Y, and they are saying X is not equals to Y. This is the question. It is really a very good question, guys. What is the answer for question number 19, my dear? Tanu is saying D is the answer for this. Okay, what about others? Guys, do like and share the session. As I said, you need to be with me till last question. If you find question or more, we can go for second part, but at least we will go till 30 question out of 50. I have 50 question around. Okay. For both branches, there are 50 question as total. Question is saying D. बहुत बढ़िया, बहुत ही बढ़िया. So guys, if you talk about this, if you are going to plot, when we are talking about X phase, on X phase, X comma 0 is the state of stress. On Y phase, minus Y comma 0 is the stress. Let us assume X more than Y. If you will go for Mohr circle, you will say that X comma 0 will lie here, minus Y comma 0 will lie here. This will be A, this will be B. You will join AB, center will be C. Taking AB as diameter, C as center, a circle will be plotted. From C, parallel to y-axis plane will give you plane of maximum shear. At this plane of maximum shear, sigma star will be normal stress and tau max will be shear stress. So we will be having both normal and shear stresses. If X and Y will become equal, then we will be having only shear stress, normal stress will become 0. Okay. If X will be Y for this question, then sigma star will become 0. Okay, I am talking in magnitude. Okay, yes, sigma star is X like this, the coordinate of center. बहुत ही बढ़िया guys. So answer is going to be D for this. This is a question from bending now. Bending and principal stresses combination it is. Here bending plus torsion plus principal stress. Everything is included. बहुत ही शानदार क्वेश्चन है. A load of 600 Newton, it is acting like this. And my dear, they are asking you the normal and shear stress in MPA. This is the best question from principal stress till date. Okay. Yes. In this, they are asking about bending, shear, everything. In the second part, the question is also very interesting. So there are two questions from the same data. Question number 20 and 21. And I feel after this, we will be entering into columns. Then after columns, we will enter into engineering mechanics. Okay. Prashant, I would like to say, I have many questions, but when I will feel that you guys are tired, then I will leave, don't worry. Questions are many in number. They are around 50. Okay, but if you want, we can have this session in 2 parts also. So that is your choice, because this is after 25 question, half session would be over. Okay. Kenil is saying A. Sagnik is saying A. Okay. So you guys are saying 67 and 56. बहुत बढ़िया, very good. So guys, if you see this load, you want to find out the effect at P. If you see this force, if I want to see the equivalent effect, I will apply two forces equal and opposite here. This and this will be making a couple, and that couple will be twisting couple for this. So my dear, if we are going to see this part, I am making it separately. It is in this way. It is subjected to a shear force which is 600 Newton, and it is subjected to a twisting couple like this, which is equals to 600 into 500. So 600 Newton into 0.5. Now my dear, you need to see the effect at outer fiber of P. So this 600 Newton will be creating bending, and this is already creating twisting. So my dear, we will be applying the formula. First of all, bending stress will be 32 m by pi d cube. You know, bending moment M will be, this is 600 into this distance. This distance is 300 mm. So it is 600 Newton into 0.3 meter. Similarly, I will find out tau s as 16 t by pi d cube, and t is already given as 600 into 0.5. So solving this, I will be getting the value of bending stress and shear stress. So bending stress would be coming out to be equals to 67.9. Yes, 67.9 and 56.6. This is the answer. The answer is, my dear, A. बहुत बढ़िया. Then, my dear, for the same question, they are asking the maximum principal stress and its location also. Maximum principal stress, you need to find out. The state of stress is known to us. This is sigma bending. This is shear. So you know sigma xx is sigma b. Tau xy is tau s. Sigma yy is 0. Is it coming out to be 0? Yes. So you need to find out sigma 1, 2. The formula is known to everyone. Sigma xx plus yy by 2 plus minus square root of sigma xx minus sigma yy by 2 का whole square plus tau xy का whole square. You need to find out the maximum value. Yes, now what is the answer? Tell me, guys. Then we will enter to the next question. Next question is from thin cylinder and sphere. Two more questions from thin cylinder and sphere. 10 columns will come. Okay. So please tell me, guys. Please tell me. Okay. हाँ भाई, Sagnik. Okay, Kenil is saying B is the answer. Kenil is saying B is the answer. So I will say yes, Kenil, you are correct. B is correct. Okay. So you will be finding out sigma 1 will be coming out to be 100 and sigma 2 will be coming out to be around 32. Okay. So this will be sigma 1 and sigma 2. So maximum is going to be 100 only. And you know the formula for tangent to theta for location. Tangent to theta P is, it is going to be 2 times of tau xy divided by sigma xx minus sigma yy. This will give you the value of theta also, and you will get B as the answer, guys. Very good, Tanu. Let us move to the next question. Now we are entering into the thin pressure vessels, my dear. Now we are entering into the thin pressure vessels. Okay. Still this is from principal stresses only. You can see this is very easy question. They have given you the state of stress. They are asking for maximum shear stress. They are saying this to be 20. And they are saying this to be 80. And they are saying shear to be 40. You need to just apply the formula, my dear. You know that maximum shear stress is given as square root of xx minus yy by 2 का whole square plus tau xy का square. So guys, if you see till this number of questions, the maximum questions are there from principal stresses. Okay. Maximum questions are from principal stresses. Second number is for SFD, BMD plus deflection part. Third is for torsion and fourth is for simple stress and strain. Pawan Kalyan is saying C, Tanu is saying C. Pawan, okay, very good, very good. This is very easy question, guys. And sometimes we have seen this type of question also. Very good, Sushil. So sigma xx is 20. माइनस 80/2 का स्क्वायर प्लस 40 का स्क्वायर. The answer will be coming out to be, my dear, 50 MPa. C is going to be the correct answer. बहुत ही बढ़िया. Wonderful, guys. This is from thin pressure vessels. This is from thin pressure vessels. A gas is stored in a cylindrical tank of inner radius. Wall thickness. The gauge pressure. Yes, guys, solve it. Very good, Rishikesh. So you need to find out the answer, guys. They are asking you tau max. Okay, first of all, I would be telling you that sigma 1 is PR by 2T. Sorry, PR by T. Sigma 2 is PR by 2T. These are the answer, sigma 1 and sigma 2 for the cylinder case. Okay. So you know, as it is sigma 3 is going to be 0. They are asking you maximum shear stress. So tau max will be absolute sigma 1 minus sigma 3 by 2. Because you know, absolute is defined as maximum of 1 minus 2 by 2, 2 minus 3 by 2, 1 minus 3 by 2. So answer will be 1 minus 3 by 2, guys. Solve it, guys, solve it. What would be the answer for this case? Yes, yes, yes. So Sagnik is saying the answer to be C. Very good, guys. What about others? Tanu is also saying the answer to be C. Yes. So answer for this will be yes, C only. So my dear, when you will be finding out 1 minus 3 by 2, it will be coming out to be 1 by 2. And 1 is coming out to be 280 MPa. So answer is 140. Yes, guys, the magnitude of maximum in plane shear stress. This time they are asking maximum in plane shear stress. So you know the formula for in plane is sigma 1 minus sigma 2 by 2. You know sigma 1 is PR by T, PR by 2T divided by 2. So this is coming out to be PR by 4T. So directly calculate PR by 4T. That is going to be your answer. Solve this, guys. I feel after this question we are moving to columns. This is the last question from cylinders. And 25th question is the last question from SOM part. Okay. Then we will enter into some mechanics questions. Then once again SOM questions will come. They are of one branch SOM question we are about to complete. Second branch questions are still pending. Anil, very good. I feel you are answering for the previous question. So my dear, with this we have completed all questions of SOM from one branch. I told you we are discussing about both mechanical and civil. So one part SOM questions are over. After next question. Yes, 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 guys. Solve this one and get the answer. It is already mentioned that pressure is 500 kilopascal. The radius of the tank. Wall thickness is 10 mm. Yes, guys. Yes, guys, solve it. Yes. Ha bhai King. Good afternoon, dear. So Tanu is saying 25, Anil is saying 25, Sagnik is saying 25, Teju is saying 25, and the answer for this question is 25. Last question, guys, from the strength of material part. Yes, last question, guys, from strength of material. Okay. So, guys, do you want me to continue, or for the other branch question we shall have on other day? Because with this half session is over. Total are 50 questions. We have completed 25 here. So rest 25 questions are for the second branch, and you can see they are interchange, means sometimes civil type of questions are coming in mechanical, sometimes mechanical type of questions are coming in civil. So we must prepare for both. Okay, even I will say that you must go for XC questions also, because some XC questions are coming in civil first, then they are coming in mechanical. So in that way they are going to be repeated. Sometimes mechanical questions from principal stresses are repeated in civil. Okay, then they are repeated in XC. So from all three, similar questions are coming. Okay, many similar questions. If you see this, consider a steel, Young's modulus is 200 GPa. Column hinged on both the sides. So column hinged on both the sides. This is the column, guys. Okay. So for this case, they are saying that it heights 1 meter. The lowest Euler critical load. So when we will find out the Euler's critical load, pi square EI minimum by LE square. LE is 1 meter. So you will find out PE as 3289.9 Newton. If they ask in Newton, you need to answer it 3289.9. Yes, very good, Sushil. So guys, shall we leave the session here? Shall we meet for the second part next weekend? This is one part over. Actually, total 50 questions are there. We have completed 25. I am having rest 25 also with me. But if after 40 questions you will say, sir, ab bas karo, then it will be difficult, because for 10 questions we cannot have different session. But for 25 we can have one more session. So we have completed 25 questions here. So if you are okay, we can have rest 25 next weekend. Okay. So in that way, every weekend we will try to complete one subject for you. Okay. If you are happy with this series. Yes, please tell me in comment section. Is it fine? Shall we leave it for today? Yes. Okay. So guys, here we will say goodbye for this session, and we will be meeting next weekend again. And from Monday onward, means from tomorrow, I am starting production technology on YouTube at 8 p.m. and I will be teaching you complete welding from all the aspects. Okay, so goodbye for this session. Goodbye. Do like the session, share the session, subscribe the channel before leaving.